Welcome back again. Goal for today is to kind of pick up where we left off last time. It was just kind of getting long, so we broke it into two pieces. What we're playing with is we're playing with unit testing in the fraction class. So as a quick little reminder on where we're at in this process, is we're writing functions for the fraction class. We wrote recently the fraction by adding, subtracting, multiplying, dividing methods. So those are now implemented. We tested them in the main function just to make sure they all printed right. And then what we've been doing lately is we made a unit test target, and we've been writing unit tests for these things. The unit test that we've written so far is we're testing the initializers. So we have two functions here that we made, and then we wanted to make sure that they were actually equal, so equal objects. In order to use equal objects, you really need to implement the isEqual method. So we implemented the isEqual method to make sure that that could work. So the task that I left you with when the video finished last time was to try to start writing some more of these test methods, so to test all the different methods we've written so far. I'm sure, like so many students, not many things have happened since the last time we talked. So let's just take a look at a couple of these things, and we'll see a few new things. So let's say we wanted to test the addition method. Well, one thing that we could do is we could make fractions for each part. So let's say that we wanted to make a fraction 1 and a fraction 2. Let's say we made 1/4 and 3/4. Then what we could do is we could make the test for each one. So let's say we wanted to do assert equals. Actually, we want assert equals objects. Let's say we wanted to compare f1 fraction by adding f2. And then we wanted to compare that. It should be 1, right? So we should be able to compare it to our convenience method, just called fraction 1, and we'll just print out 1 was not 1. Some of my descriptions are not very clever. So this is a totally valid way to go about doing your test. Let's do a Control B, test it, and see if this works. Looks good. Because I'm a big worrier, and I worry about my test not actually running, I'll stick in a fail. Yep, my tests are at least running. I just do that because I don't feel good about the way it confirms that it works. I always fear that they just didn't run. So this is totally valid, but I also want to teach you additional skills, and the skills that I want you to make sure that you learn are setup and teardown methods. So let's do it a little bit first. So what we're going to do is into the header file of the unit test, so of the test area, we're going to make some ivars. This seems kind of weird because we're never going to make instances of this class, so why do you need ivars if you're never going to make an instance of it? Really, it's just a class-wide pointer. And so right now we've made a pointer to a fraction object called 1/2, 1/4, and then also 2. And what we're going to do is there are some built-in methods that you can override called setup and teardown. This is pretty common for unit tests to have a setup and teardown. So you can see that this is based on top of the send test case class, and this is something it has built in. So these names are important. You have to make sure the names are right. You're overriding a method. The idea of setup is that before each test runs, it runs the setup method, and then after each test runs, it runs the teardown. So you can put things in here, like you want a fresh object each time, you can put it in setup, and then it won't get, if you modify it in another test, you'll still get a fresh one at the start of each test. So what we're going to do is we're going to use this setup area to create objects for each of these pointers. So for the 1/2, 1/4, and 2 pointers, the pointer's already been declared, so I don't need to declare the pointer again. But there's no object for it yet. So let's go ahead and make an object for it. We'll go ahead and use the designated initializer, init with numerator and denominator. So 1/2, we'll make this guy. And then we'll need one for 1/4, and then also for 2. Nothing sacred about these. I just kind of pick some to show you the idea. And then if we wanted to be good memory management citizens, we can release them. There's no real reason to make a property for something like this because you're making it once. When you make it, you give it a retain count of 1, and so it gets made and set up, and then it gets released in Teardown. To be honest, a lot of people don't worry about memory management with unit test because it won't be like on the shipping code anyway, right? It's just, it never really leaves your computer. So if you have memory management errors in unit test, I mean, who really cares? But it's a good practice, right? So we're gonna try to do things right. So the idea is now if you're writing test, you've got in addition to your convenience methods, you've also got these built-in things. So if we wanted to say st assert equals equal objects, I could just say if I wanted to take 1/2 and make a fraction by subtracting off 1/4, I know that that should give me back 1/4. And then in my comment, I'll just write out what I'm doing. And so you can use this setup and teardown method to just create objects for you that make it really easy to create test, right? One test that I wanted to mention is the division one. It's got an interesting property associated with it. If you recall, the way we set up our designated initializer is that if somebody tried to make a fraction with a 0 denominator, that's an undefined fraction, what we chose to do is instead of throwing an exception, we just return nil. It's just kind of it's kind of the Apple way, is to not mess with exception handling often, and just return nil. And if somebody really needs to deal with or watch for that, they can just see if it's nil or not, and they can work it out. So in our unit test, we can do things like making sure that something is nil. So we can say assert nil. So let's say we were to take any fraction, let's just take 2, and make a new fraction by dividing 0. So we have a nice class method for a fraction of 0, and that should be nil. So division by 0 did make a fraction. So if that test were to fail, that's what would print. And so you can see how assert nil could be useful. The other ones that you'll use sometimes are true and false. To be honest, usually usually you could express anything in terms of true and false. So for example, you could say, so we're in the test division area. So let's say we had 1/2, and we made a fraction by dividing 2. And you know, we could say, is that equal to 1/4? But you could also say, you could call the is equals method directly, and we could pass it in 1/4. And then we could just say 1/2 divided by 2. I suppose I should put these in parentheses. Doesn't matter there actually. Is equal to 1/4. Who I should say not equals in my message. Likewise up here I should have said not equals. So you can see how you can use these different types of syntax error somewhere. Right there, I need a bracket. So you can see how these different assert things could be useful. To show you one more assert, we're going to have to make a new method, or I'm going to choose to make a new method. We're going to make a new method called FloatValue. And really the main reason we're doing this is just to show you the st assert equals with accuracy. I'm pretty sure I've got that typed in right. Yeah, it usually turns nice and gray for me. So what we're going to do is we're going to, so we've done the setup to teardown. We've done the assert that it's nil. We're going to add a new new method called FloatValue. The idea of FloatValue is just so that we can get a floating point representation of the fraction. This name was chosen because it was the most consistent with what the NSNumber class does. So NSNumber is just a wrapper for primitives. It's kind of like integer in Java. So NSNumber has these float value where it gives you a float. I mean, you could write as many as you want, right? There's also a double value, which is the same thing, just a double decimal value. That's interesting how it uses an NS decimal. I don't really use NS decimal much, but it's the same concept as NS integer. So we're going to make a float value. You should hopefully be able to write float value on your own. I should have given you a chance to do it on your own, but we'll just go ahead and implement it here. So if we wanted to get a float value, I'm going to put it into my instance methods area. I just take the numerator, I typecast it to be a float. Then if I have a float divided by an integer, the compiler will bring the integer up to a float automatically for me. So this will just return a floating point value. And so now we could do a comparisons with accuracy. So if we were to test 1/4, it should be equal to 0.25. I'm going to intentionally let there be a type mismatch arrow here just so you can see it. And we'll say float value not within accuracy. So let's go ahead and build it. And oops, I did mistype this. Let's see what it should have been. It should have been assert equals, not equal. So picky. My auto-completion let me down there. So if I try to run it here, it says that there's a problem between something and a double. The problem is really that these should be the same types. Some of their messages aren't great. So this should be of type float. You can put an F after it to make it a float if you'd like. That's the easy way to do it. Oops. I forgot to... I was trying to show you something there, but my real problem was that I never called float value. That's a bigger problem. Let's call float value. This is where doing things in class is nice. I would have had 20 people like yelling at me for saying, you know, what are you doing there? All right, now it did the error that I wanted. Type mismatch. And the type mismatch is this 25 needs to also be of type float. If you put it in here just as 0.25, it's of type double. So we can fix that. This one's okay to be a double, it doesn't care, but this one has to be the same value as this. The F after is the more common way. You could also type the word float specifically. The F is just a convenience, just because converting things to floats, like it's a double now, there it's a float, can be so useful. And the difference is, for those of you not as familiar, is the number of bits it takes up in memory. Floats are, what, 32 bits, depending on your target, and then doubles would be twice that, so 64. So they have a different size, you know, mantissa and exponent. So that's float value. So just learned a little bit about that so that we could use assert with accuracy. Now you've hopefully got a real good feel for all the different tests that you might use, right? So these are the tests that are most common. Hopefully you feel comfortable with all of them. They're easy, right? Unit testing is not meant to be hard. It's meant to be easy. And hopefully you've got a better idea of the setup and teardown and how you can use those. Cool. So let's go ahead and keep moving through a couple different things. So that's kind of the end of the tightly packed unit testing lecture that I wanted to get together. But there are a few other methods that I just couldn't pass up. A few little like loose ends here and there that I couldn't pass up, and now seemed like as good a time as any to kind of start talking about them. So these are the topics we're going to go through. We'll just kind of hit them one by one. The first one is that comes up with unit testing is people want to print out an NSLog while they're testing. And so if you were to put in an NSLog message, so unit testing is really good to make sure things are working, but if they're not working, you've got to debug it somehow, right? So you might want to print out something like 1/4 equals this, if the 1/4 value wasn't what you thought it was. A good debugging technique is this NSLog, and if you were to hit Command Enter right now, and you've got something in the NSLog, you can come over here and you can look for it in the NSLog. What I did to bring this up is Command Shift R. This is the GDB log. So the GDB console is an active, like, while you're debugging, while you're running. So this is a GDB console. And there's nothing running here. The unit test didn't actually run an application. So nothing's going to show up here, right? So no NSLog message will show up in the console, right? So I mean, you can see it's under the run area. We didn't run it. We hit Control B to build it. So nothing ran. However, it does show up somewhere, which is nice. If you just type in the word console into Finder, there's a program here just called console. This is your system console. You can see I use it so much it's sitting right next to Xcode on my icon because I use it all the time. And things do go here. So you can see where I typed 1/4 there. If I clear it off and I just build it again, you can see how it put 1/4 back. And so every time you run it, things do go to that location. And that can be extremely handy, just to know that those NSLog messages go somewhere. Because when you're really having a trouble, NSLog is so useful for debugging. You lose some of your debugging skills with unit testing, which is a shame. But NSLog has survived. You just have to know where to look. Next up is target dependencies. Let's do something. Let's go ahead and let's say we wanted to add some more things to the bottom of our Fun with Fractions main M file. So inside the main M file, what we're going to do is we're going to print out some more stuff. So let's start off with just something basic. So more stuff. Right now, if you hit Control B to build it, it'll build it. If you hit Command Return, it'll kind of look like it ran it. But you'll notice something odd. It didn't say more stuff, right? So it didn't say more stuff. Actually, it might have just done nothing. So if you hit Command Enter, it might say no binary even, which is what I was initially hoping. Mine did do stuff, which is interesting, but it didn't do the latest stuff. So what's that all about? Why can't I want both, right? I want unit testing and I want it to call main. I want it to do both. So the reason it didn't do anything is because this target, if you click on this target, you can see this target only includes these two files. So we're making changes to a file that's not even getting compiled, right? So any changes in here, they're not even getting compiled. I mean, certainly they're not being run. They're not even being tested for problems. If you want the best of both worlds, there is a way you can do it. And what you do is you add a dependency. So let's go into our unit test, click on Info, and under the General tab, you'll see that there's a Direct Dependencies section. What this means is if this target depends on another target, it builds that other target as well. So we're just going to click on plus, and we'll add the main target as a dependency to this target. So now that it's a dependency, if I was to do the same thing, hit Command Enter to actually try to run it, it would in fact build my unit test, and it would build my main project as well. This is extremely useful. The reason this is so useful is, and this is better than what Java does as well. Well, Java, I'm sure there's a way to do it, but I don't use it. Unit tests, typically they're kind of run once, and then there's this problem of programmers forgetting about the unit test. And to be honest, if you don't have a way to regularly run it, it'll be months before you run your unit test again. With this solution, you can run your normal app, but you can run your unit test at the same time. So just every single time you build, it runs your unit test. So the way programmers use it is like this: is they make their main target, they make their unit test target, they make a dependency connection, and then for the entire development lifecycle, they always use the unit test target. And then at the very, very end, before you submit it to the App Store, then you switch your active target back to the other one. It's a really great way to keep running your unit test, hundreds of times a day, and it's so fast that you barely notice. All right, now instead of just saying the words more stuff, let's actually do something kind of moderately interesting. Let's go ahead and let's learn a little bit more about arrays. So we haven't actually discussed anything about arrays yet. So in the class this will be something new officially, but hopefully some people have seen some things from the book. An NS array is Objective-C's standard array, similar to an array list in Java. I keep making the Java references because people in this class should have taken CSSE 220, which is a Java-based object-oriented programming class. So it's similar to an array list. It is also different in a few ways. An array list in Java, for example, you tell it what type it holds. An NS array doesn't care. And an NS array holds pointers, and they can point to anything you want. They just have to be objects. So only objects can go into the array. That's just like array list. And you can see that some of the objects that I'm putting in here, I put in a fraction 0, 1, -1, and then I grabbed various fractions. I'll tell you what, let's make sure nobody gets released. Actually, that one would be fine. He's auto-released. F4, we'll need to move him down. Otherwise, he'll go away on me. And then we've got up through, we've even got an F7 in this project. So we're making an array. In order to make the array, we're going to use a class method. This is a convenience method called array with objects. That means that the array object is in the auto release pool, so you don't have to worry about that. And it adds a whole bunch of objects to it. This method, array with objects, has to finish with a nil. This is sometimes sneaky because if one of these is accidentally nil midway through, it'll cause trouble. But it ends with a nil, and you have to know that none of the others are nil before you call it. And then if we were to print it out, if we were to print out that fraction array object, it actually has a really nice description method where it makes each object on its own line, and then it calls the description method for each object. Let's just go ahead and see how it works. Hit Command Enter and go ahead and run this. Command Shift R to bring up the GDB console, and you can see that it prints out the fraction array, and it prints them out in the order that they're in. Right, an array is an ordered list, so 0, 1, -1. You could read the rest of them. So what we want to do is we would like to sort this array. So the goal is to sort this array. So let's see how that's done. So how is sorting done? So sorting is done, I kind of got ahead of myself here. Sorting is done with the compare commands. The compare commands, if you look up a couple examples, if you look up NSstring, NSstring has a series of compare commands. Oops, I'm in the wrong place, now I'm in the right place. So it's got a series of compare commands. That's because it's got like compare with options and all kinds of things. But the basic compare command is of this style. It returns an NS comparison result. An NS comparison result, what it is it's actually an enumerated type. And it gets passed in a pointer to the type of class that it is. I was surprised by this when I first saw it because I would have expected it to be just ID, but it's not officially part of, like in Java there's a two-string interface. In Objective-C there's more just like a standard you follow, and so you can just pass in the type of object that it is. They don't mess with the ID thing, which is fine. It works out fine. The thing that it returns is an NS comparison result. An NS comparison result is really just the numbers -1, 0, and 1. So if you wanted to, you could do exactly what Java does and just return -1, 0, and 1. But they give them names, NS order ascending, same, or descending. But it's really just an integer underneath the hood. So we're going to return one of these three things. And there's one of these on a lot of methods. So like here's one for date, and they always return one of those three options. So let's go ahead and write this function. The first thing we need to do is we need to put it into the header file. Whenever we call it, this is what we're going to call it, and it's going to look like. Got ahead of myself a little. Let's go ahead and add that first. So we want a sorted array. So we're going to use NSArray has a function called sort array using selector, and we're going to use the compare method. Since we're passing in an array of these objects, the compare will get called for a fraction class. Officially, this is something new. We're going to say sorted array using selector. What a selector really is it's a function pointer under the hood. And Objective-C makes it really, really easy to make function pointers. There's no like weird syntax. You just say @selector, and then you say the name of the method, right? So this one is compare colon. The colon is part of the name, so this is the compare colon selector. And once we do that, so long as compare works with one of those three responses, it will just sort the array for us. So let's go ahead and implement this guy. So step one, oops, I apparently didn't have the code for it here. So step one is to put it in the header. So into the header we're going to go ahead and put an NS comparison result, and it's going to be called compare. It's going to be passed in a fraction, and you can give the name here whatever you want. If you compare it to these guys, one used a string, another used another date, it doesn't matter. I'm going to use another fraction because that's what I've been using. Yeah, I would have expected it should be a protocol, which is something we would have done up here, but it's not. It's just a function with an expected style to it. And so whenever we write this, we're going to return one of three things. We're going to return one of these guys. So let's just go ahead and copy these, just so I know what we're going to be returning. And so somehow we need to return those things. So the way that I'm going to do it, we could, if we wanted, use our equals statement. If you wanted to try to make your code more reusable, since we know we've got an equals, we could use it. Or if you're feeling particularly lazy, you could just be a terrible programmer and copy paste. I don't know why I feel like being a terrible programmer today, but I kind of do. So if the numerators are the same, oops, that's what I get for copy paste. So if the numerators are the same and the denominators are the same, then we want to return a value of NS order same. If that is not the case, if it's actually something different, we want to return one of these guys, So we're either going to return NS order ascending, or we're going to return NS order descending. Now, for figuring out which one you return, you have to draw on all that junior high math skills. So we've got two fractions, if you can visualize it in your head. Let's say we have, A over B. Oops, had to quiet Kingsley a little. So if you're trying to compare A over B to C over D, we can simply just multiply through by the denominators. And since they're guaranteed to be positive, we can just see if AD is less than CB, then we know that the fraction on the left is less. So if we were to say self.numerator times another fraction's denominator, if that is less than another fraction's numerator times self's denominator, then we know that self is less, and if self is less, that means the order is ascending. So from when you call it, the order would be ascending. And otherwise it'd be descending. And we could, of course, test this with a unit test, and that would be a totally valid way to test this thing. But since I've already got the sorted code here, I just want to run it on main, and just we'll know real quick if it works or not. So if we run this guy, hit Command-Shift-R, we can see that it prints out the array in the initial order. So this is the order that I made it in. And then when I say sorted array using selector, it should sort the array using the selector that I made compare. And you can see that they're now in the right order. -2, -1, a couple of them were 0, 3/4, a bunch of them were 1, 5/2, and 7. Did some interesting thing there with the descriptions, whether it chose to put quotes around it or not. That's interesting. I'm not worried about it, just interesting. So you'll see compare methods a lot. So I wanted to show you the compare method. So we're working through these kind of like little odds and ends. Compare method is neat. So I showed you that. NSLog is neat. Dependencies are very important. So I showed you that one. Let's see what's next on the scattered topics. So the last scattered topic that I've got for you is class variables. So we've talked about instance variables a lot. So instance variables are independent for each instance. So each instance object gets a fresh independent copy. But there is also something called a class variable, which is shared by the whole class. These are available in pretty much every object-oriented language. One funny thing about this is class variables, they were around in C, right? So C had module level variables that were usually declared static, so they couldn't be externed by other functions. That's been around since the 70s, right? So Objective-C didn't add anything for class variables. It just let the module level variables that C already had serve as class variables. And officially the scope on the module level variables is actually anywhere inside the implementation file. So they can be used in instance methods or in class methods. So they are kind of different from other languages' class methods or class variables, but they get the job done. So let's see an example. So what we're going to do is we're going to create a class variable. It's going to be a rather lame class variable. So there is no reason that this class would need a class variable. You should almost save it and start a new project because it's so pretty right now. We're about to corrupt it with a bunch of garbage. But I wanted to show it to you, so we're gonna. So the way you make a class variable is typically, you can place it in a lot of places, but people typically put it just after you synthesize any properties. What I've done here is I've made a variable of type NSInteger. It could be anything. It could certainly be a pointer to an object. That's very common. But here it's just an integer. I went ahead and declared it as static. This is a C thing. If you want to make sure that nobody externs it to somewhere else and makes it a global variable, that's a dirty word, right? If you want to make sure it doesn't become a global variable, you need to declare it as static. The variable that I'm going to make as a class variable is I'm going to track how many fractions get created. So I'm going to have a number of fractions created. I'm going to start its value off as 0. Totally fine to go ahead and do a declaration and definition together for primitives. If it's an object, you can't do the alloc up here because that's running code, but you can do a definition for primitives. And what I'm going to do is I'm going to just kind of hack in a place where this could be used. What I'm going to do is inside the designated initializer, every time I make a new fraction, I'm going to increment the number of fractions that have been created. I'm going to label it as a hack because it doesn't really need to be here. It's just an example. I'll quit saying that now. And what I want to do is I'd like to have some way of reading it. And the way that I'm going to read it is I'm going to make a class method. Good practice for class methods. And the class method is really just for reading that value. And the class method is going to just be called number of fractions created. So if somebody calls this class method, it's just going to return that class variable. So if we go implement this, I'll stick it at the bottom of the class methods area. You can see that I try to keep things fairly well organized. So I've got like my class methods, and they're all right here. By the way, I hit Control-2 to bring this up. I've got my instance methods, and they're all right here. You could even break this down farther and break it down into like initializers and then like other instance methods. I've got my NS object overrides that I've made, and then I've got my internal methods at the bottom. I choose to put them at the bottom. Some people put them at the top, but you can see it's good to be organized. So you can make surfing this class in the future very very easy. All right, so it's just going to return this, and then now the last thing I need to do is I need to call this class method from main or somewhere where I can test it. And so what I'm going to do is, like after I make one fraction, I'm going to print it out here. And then I'm just going to stick this in various places. You can see I put these hyphens on just so you can see it. So after I make 1, and then I'll do it again after I make 2, and then we'll just kind of stick it down here after. It looks like I've made 7 at this point, so 1, 2, 7. This is interesting. These all make fractions. So all of a sudden we just made, whatever, 8 more, so it might be 1, 2, 7, 15-ish. And then by the end we can see how many we made total. My count was not exact there. But you can see that it prints it out at various places. Looks like I meant to say 16 somewhere. So after 1, 2, 7, and then it looks like we've made 16 at this point. Oh, I think it's because subtract actually makes 2. So if you look into the code for subtract, it's kind of memory inefficient. I'll look at that after. So you can see how many fractions have been made, and then at the end we've made 19 fractions. It's also kind of neat because we've made 19 fractions, but everybody's retained count finishes at 0, which is kind of crazy. Let's just go and add on one more thing just to kind of be fun here. If you wanted to, you could see what the retain count is of an object. So f1's retain count is %d, and there's a method just called retain count. So we can print it out here. Let's try to make it easy to find just because we're starting to get pretty large. So let's print it out there. Then this will be interesting. After we put it into these arrays, let's print it out a couple times. And then after we release it, let's print it out. And this will be kind of wacky. We can see that we made it. We made the fraction, and its retained count is 1, which is exactly what you would expect. And then this is interesting. Down here it got to 2. Then down here it got up to 3. How did this happen? How does this retained count keep going up? The reason it goes up is when we made this fraction, or sorry, when we made this array, and we put fraction 1 in there, all of a sudden this array cares about fraction 1 as well. So it put a retained count on it. So you can see that I printed it out after it was in that array. And then all of a sudden, this function makes a new array. And you know what? F1's in there too. So at this point, it was 3, which is crazy. And then here we released it, and it went back down to 2. And then the pool gets drained. When the pool gets drained, this array goes away, which it then releases all of its members, so it's back down to 1. And this array goes away, releasing all of its members, which brings it back down to 0. So it's crazy that we've made 19 fractions, and we very carefully made all 19 finish the program with a retained count of exactly 0. It's almost magic when you make a giant program and it has, I mean, literally thousands of objects. And every single one of them, of their 1,000 objects, finishes with a retained count of 0. No more, no less. This is why garbage collectors make your life easier. Because when you're in charge of memory management yourself, you've got to make sure to make all 1,000 objects finish at exactly 0. It's not quite as hard as that, though, because if you follow the guidelines that Apple kind of sets up for you, there are ways to make it really easy to make sure that magic always happens. So that's the end of our crazy long fractions example. Pretty much all of it was useful except for this fractions have been created was kind of something I stuck on there. But I think it's a really neat example that gives you a good idea of creating a model class, something that would be kind of like a back end that you might use. One shortcoming of this example is that the ivars were primitives. The next examples we do will use ivars that are actually objects, and that'll force you to learn a lot more about memory management when the ivars are objects. So that's finally the end of the fraction class. We beat this horse to the ground over many days, but hopefully you got a lot out of it. Cool, catch you next time.